build world. World. Did you like? I was trying to keep to the beat there.
Hey,
Hey, what's up, everybody? How's it going?
hey, how's it going?
Great to see your face again, GGG. How are you doing?
Amazing. How are you doing, Dan?
Pretty good. Yeah, I can't complain. Yeah.
What are we going to learn today?
What are we going to learn today? It's going to be smart contract development. So we're going to be diving into Hardhat, and we are going to be learning basically all the smart contracts that I think you would need if you're going to build this the most basic way that I picture. Right. So like Tabo asked a really good question last week about the approved transfer from flow for NFTs. It's basically what I plan on doing here today, and then talking a little bit about Gasback and how that works on Shape. And so we're going to be doing a lot of smart contract development with our AI friend. Claude is going to be helping us out quite a bit. And we're going to be talking about the incentive, the collaboration incentive that I think could be pivotal for Web3 gaming.
Yeah,
And
super important, essential.
heck yeah. All right, cool. Any last words before we jump in here, GGG? Anyone have?
No, just
Sure.
a clarification, probably for some of you.
Oh, sure.
Is this session is 1 hour later? This is due to some daylight time saving around the world. So just in case, always check the events in Discord and the announcement, just to make sure that you got the correct starting time. That's all.
Yeah. Thanks for pointing that out. Hopefully, we won't lose too many people from that. If people tuned in an hour early, we apologize. Daylight savings time, it's really screwy. We got to get rid of it. How do we do it? I saw a post from Vitalik Buterin like maybe a year ago or something where he was like talking about how to get rid of daylight savings time. I'm like, nothing escapes this guy. He's coming up with solutions for everything. But
Yeah.
really, it's sticky. It's a tough problem. Oh. GM to everybody. Awesome. All right, let's jump on in here. So, super excited to begin today. Also, super excited if you guys haven't been checking it out, the video game development streams that we do on Thursday. Ton of development happened after we closed the stream on Thursday, where just a bunch of folks have like created their own versions of it. Talon Dragon, who's just really getting her hands into development, was able to get it up and running. We had Tabo drop some Dan Nolan NFTs. I think they're supposed to be me, right? They kind of look like me. And then we had a character select screen from a guy named Danny, posted it up on Twitter. So going to be pulling that in on Thursday, so make sure to check that out. Nan Dolan, yeah, that's a good one. That's like not a number Dolan, like you know how you get Nan whenever you like add a number in a string in JavaScript. I am Nan Dolan. All right, here we go. Let's jump on in today, and we will get started with what I have prepared. So we'll do my entire screen. And I, as normal, will start off by letting you guys know to make sure to register for Shapecraft if you haven't already. It's coming up real soon. So that's maybe a week and a half from now, November 18th, just after DevCon. For any of you folks going out to DevCon, enjoy it. And I will not be there, but a bunch of folks from Alchemy will be. So, stop on by and say hello. For everyone else, we'll be here doing live streams throughout. We're doing it still the Wednesdays and Thursdays. Make sure to register here on Shapecraft. Cool. So we're going to be jumping on into Hardhat today. I also want to go back into Escala Draw just to sort of draw up here what I want to talk about from the very beginning, which is going to help us like sort of frame this again, right? Because we're using AI, I'm not going to be doing as much coding here as much as I am going to be prompting and just fixing what the AI sort of puts into the code editor. So if we run into any issues, so it's really helpful, I think, to like think from the top level architecture, what we're doing, and we'll come back to this. If anyone has questions about the architecture, those are the questions I'd love to answer in this session, because I think that's really, really important. The big thing here is, so we've been learning about game development, right? Inside, so let's do a couple shapes here. I'm going to make this one the same size as this one because these are worlds right here. So this is going to be, let's call this world A. Let's call this smart contract world A because this is going to be a smart contract. And then this is going to be smart contract world B, right? So GDG, do you want world A or world B? GGG.
I would choose B.
All right, GGG is world B and I am world A. So we both deployed these two worlds. I was the deployer of world A, and then GGG was the deployer of world B. That's just going to make it a little bit easier for us to sort of make this a little more personal as I go through the example. Did anyone watch that show Dark? I think it was like on Netflix, and it was they kept talking about your world and my world. It feels very similar here. That was an interesting show. All right, cool. So these two are going to be on chain here, and we're going to make this the chain. So let's do that here. This is going to be the chain. So that's going to be on chain. And then in our other streams, we've been talking about servers as like video games, right? So like I might run a video game server and I want to make this like a regular line here. So let's do that. I might run a video game server and GGG might as well, right? And these video game servers, what they're going to be using the smart contracts for is basically reading where the items are for different people, right? So this would be game server A that's going to be talking to smart contract world A, and this is going to be game server B that's going to be talking to smart contract world B, right? So essentially, the way that this is going to work is you might have a bunch of users, right? And so, do we have some names? Tabo, I know. Do we have anybody else that we can shout out in here? User 2, user 3. Who else is out there? Yeah, it's gonna be tough for me to spell the name. So Tabo, you get special honors there. I'll get more users, but we'll have 3 users there. So we have a bunch of users here that are going to be sending some items from world A to world B. And essentially, what you're going to have is these users are going to own NFTs, right? And these NFTs are going to be themselves their own smart contract. So let's just say both of these worlds implement an NFT collection that's called like swords, right? So this is the sword NFT collection right here. And Tabo is an owner. Let's just do Tabo here. Tabo is an owner of the sword NFT. So Tabo has one sword NFT. And what Tabo can do is he can bring his sword. So let's just do Tabo's sword. And we could say is token ID, let's say 12. Right. So it's important to note that for NFTs, and we're going to see this in a moment, that for NFTs, when you deploy the smart contract, you're really deploying a collection of NFTs, right? Because each one has its own token ID, unique token ID inside of it, usually counted up from 0. So Tabo's sword specifically is token ID 12. So he owns that particular token ID. So what he can do is if he wants to be able to move it from world A to world B, is from the outside here with a private key that Tabo controls, Tabo can say, I want to call into sword NFT to basically then move this sword into Dan's world, right? So now Tabo's sword is here. When this happens, this flow right here. Now, Tabo asked this great question last time, which is why I'm using him as an example here, which is talking about the gas back and how this would actually work underneath the hood. Today, we're going to use the approved transfer from flow because that's like a pretty common flow. But there's other ways that you could do this too. You could there's like inside of the NFT standard, there's also a way to recognize that the contract that you're sending it to is a smart contract and give it access to be able to then run code. I'm just going to do the approved transfer from flow to keep it kind of simple here. But what would actually happen is Tabo would first call into the sword NFT and say, I approve Dan's world A to transfer from the sword NFT, or transfer from me, my address, to Dan's world, the sword. So what happened, and then after that, we call into world A, and then world A actually transfers over from Tabo's address here into the world A. So that's a little hard to show on the diagram, but what essentially happens at the end of that is the sword, you can think of it as moving from Tabo's address into smart contract world A. Now, what happens in this flow is there's 2 contracts that are being interacted with. One is the sword NFT and one is the smart contract world. And when it comes down to gas back is going to be calculated where it's going to on the Shape blockchain, it's going to see these calls, right? So the first call stack is going to be approve, which is going to go to the sword NFT, right? So that's the first call. And then the second call is going to be this transfer from flow, which is going to be smart contract world A, or let's call it Dan's world, right? Dan's smart contract world. Table is going to call into smart contract world to import the item. And then that is going to, from the smart contract world A, it's going to make a message call into the sword NFT to transfer from. So in both cases, the sword NFT contract is actually getting called. But in the second call right here, we're actually importing the item. We're calling Dan's world directly. And so Gasback is going to do a calculation of basically the gas that it costs to import this item and to store something on smart contract world A that this item was imported at this point. And by doing that, every time that an item is imported, or if we decided to move Tebo's sword over to GDD's world, every time that it's exported as well, you will get some of this gas back, right? So there's this incentive to want users to move the sword from world to world, right? So we could also move Tebo's sword over here, in which case there'll be another call into GDD's world to import the item and transfer from, maybe over from Dan's world. And Dan's world will also have to call like an export item or do some other additional like logic to allow GDG's world to then transfer over from it, right? So each time that we're doing this, Tebo's sword is moving from game to game. And each of these contracts by default via the gas back mechanism, there is the calculation for how much gas was spent is going to go to the owner of that contract, and they are going to automatically earn from these swords being moved across the worlds. So what essentially happens there, right, is there's an incentive for me not to, as a game owner, for me not to have a walled garden, for me to actually want GDG to build something for Tebo's sword, right? Because if GDG builds something for Tebo's sword, and then Talon Dragon comes and builds a world for Tebo's sword, and then another dev and another dev and another dev all build something for Tebo's sword, the sword's going to be moving across all of these worlds, right? And when it does, as people are trying to try the new content across all these different worlds, you'll be getting paid as somebody who is providing content that makes this sword interesting in your particular world, right? Which creates this sort of collaboration incentive. Now, on the game server side, what we'll be doing here, which we're going to connect the dots here next week, is we're going to be reading whether or not this sword is inside of the smart contract, right? So you read to see, hey, is that sword currently in the smart contract? And who is it owned by? Is it, this person here who's logging into my game server? And if it is, then go ahead and render that inside of the game itself, right? So we'll have the server, just like we do in the game development streams, where the server is actually going to determine from the chain where the sword is actually located. And then that's going to render on the client. And of course, that's going to sort of authoritatively decide what the interaction table can have with that particular world is, right? So this would be a very basic example of data sharing across worlds. You could imagine that if your games are more similar, like if you are building an RPG and you want to have like similar progressions, or like maybe my world handles level progression from level 1 to level 5, and then GDG's world handles it from like 6 to 10. You could also imagine us sharing progress, right? Or pets or achievements or something like, or aesthetics, right? Something that you wear inside of all these different worlds. So the sword just happens to be like the most simple example here, but you could imagine really anything, a consumable potion or something like that you want to bring to these different worlds might make sense. So yeah, this is the high level architecture of what we want to accomplish today in smart contracts world. It's actually not going to be that much code. It probably won't take me very long, so we can come back to this and kind of discuss like the incentives here and maybe talk about the architecture on a more high level. But would love to take any questions if we have them before we jump in there. GDG, do you see anything in the chat?
Yeah, I think there's a put it on the screen right now. I don't know if you can see it. If not, I can read it. This is a fair question, a good questions. If we were clear on your explanation that you are giving the ownership of the Tebos Sword NFT to the World One and then to the World Two.
No. So you won't give ownership of it. That's a really good question. Thank you for asking that. You won't give ownership of the NFT to those worlds. You're just basically putting it in there. But the worlds, the smart contract, you'll see in a second, will be written in a way that you could pull the sword out at any time. And only you, the person who put the sword there. So it's being held in escrow. Essentially, you could think of it that way, where it's basically, you're basically saying, this is where I want the sword to live, which is like the incentive, the monetization for the games to render it. But at any time you could export it, and only you can export it. And that's written into code. And ideally, these worlds will be non-upgradable if possible, so that if the worlds are just deployed and that's the code, that's how it always is, right? You don't have the possibility that somebody could ever move your sword, so you don't have to give up any trust there. Yeah, thank you for asking that question. That was a really good one that I did not point out. Super important. Cool. All right, then let's go ahead and jump on into the code, and you guys will see exactly what I mean. That was a super relevant question by Dev Relevant. Awesome. Here we go. Let's just jump on into the rest of the code here. I'm going to share, and we'll pop open iTerm, and I'm going to create just I got like my temp repos. And what are we going to call it? Let's call it like Tebo's Sword Fun. Hopefully Tebo doesn't mind me using him as a example. And hopefully that's how you say his username here. I don't know. I've just been saying it. What do you think, GGG? Am I right? Am I wrong?
You're always right. No matter what.
Well, Tabo will be the judge of that. Okay, awesome. So let's go ahead and we're just going to start a new repository here with package JSON. So when you do npm init y, that's just going to create a new package JSON. And we're going to do this because Hardhat, which is what we're going to be using for our smart contract development here, is a JavaScript framework. It's going to have Solidity built inside of it, but like the scripts and how the project is managed is very much like a JavaScript project where you have a package JSON, so you can pull in like new dependencies. We could pull in dependencies, as you'll see in a moment, also Solidity contract dependencies, like we're going to use Open Zeppelin. That's going to be really important here. So the first thing that I'm going to install here is Hardhat, and we're going to say this is a dev dependency. So that's what I'm going to go ahead and install. And hopefully my internet's pretty quick here. So that'll only just take a second. And once that installs, then we'll create ourselves a new Hardhat project. And we're going to start with our NFT. So let's say npx hardhat init. And to be quite honest, I am a little bit rusty with Hardhat because they went to Hardhat Ignition, and I haven't been using it as much there. So forgive me if I misuse Ignition. I don't think I'm a power user of Ignition. I'm so used to scripts just yet, but you guys will see how to use them. And if people have good tips for how to like set up the modules in a better way, do let me know. Would love to see it. Definitely toss it in the comments below or out there, and we'll call on you in a minute. Okay, cool. So what we're going to do is we have this contract. So Hardhat, the way it's set up is you have these contracts right here. This is your smart contract. And then Ignition is the thing that I was talking about. That's kind of new in Hardhat. I'd used it a long time when there were just scripts in here, but Ignition is this really cool thing that you could like set up all your deployment scripts in like a declarative fashion that lets you just do a bunch of things. It's going to keep track of all the deployments that you've done across all the different chains that you've done, so you can really like manage it super well. And I'm sure there's a lot of other benefits there that I just don't have a full grasping of, but we'll see the Ignition in just a moment. This is going to be for our like deploy scripts that we're going to run. So the particular example right now that they have in here is this lock contract. And then when you want to deploy the lock contract, you can see what it's doing is it's creating two parameters, and then it's deploying this contract right here. these ignition scripts, once you write them, you could use them for any chain that you want to deploy on. So the first thing we're going to deploy to is just a local node that we're running in memory. We're going to run it inside of a process and in the terminal, and we're just going to deploy some contracts there. But when we're ready to deploy it to Shapesapolia, which we will do in a moment, we'll be able to do that just as easily, right? We'll just be able to run the same scripts once we test them out there. The last thing I want to point out here is these unit tests. The unit tests in Hardhat are typically done in TypeScript, but you could also set this up so you could do like Solidity testing. You could pull in Foundry and Hardhat repositories and put them together, which would be really nice. When you want to do like really tight unit testing, Solidity is probably the best way to do it. If you're looking to do it like pretty quick and you already know JavaScript, TypeScript, unit testing and Hardhat can be really good, especially when you're trying to like unit test across many different smart contracts. It's a little easier, I find, like if you're having to deploy it and you want to like test a couple different things that have to do with the way that you set up your contracts. Okay. Cool. So then the last thing I'm going to point out to you is this Hardhat config. Right now, the only thing that it has is Solidity at 0.8.27. So that's a compiler version. In a moment here, we're going to be setting it up so that we can also deploy to Shapesapolia. So when we do that, we'll come in here and configure it there. But that's basically everything you need to know about Hardhat. Even if you're coming in here for the first time before we begin, what I want to do now is I want to do that NFT contract. So if you're not familiar with NFTs, the most common version of an NFT is ERC 721. ERC 721 is the pretty typical NFT standard. So there's a couple other NFT standards that make it easier to do like batch transports and things like that. But the ERC 721 is the most typical standard that you will see. So that's what we're going to be using here for Tabo's sword. So let's go ahead and create like a sword contract. I'm going to call this sword. And I'm going to ask AI to do some of this for me. So, hey, could you create a sword NFT here using Open Zeppelin's ERC 721 implementation? I would like one function called mint that allows anyone to mint a sword to their address. I think that's it. That's really all we want. The sword, we want anyone to be able to mint the swords. Something that we'll have to think about a little bit later as well is like how you want to distribute your items in the game. And if you want your items to have any real value associated to them, you're going to want to do that in like some sort of like Sybil resistant way, right? Where there's no like, where bots can't just like farm it. Otherwise, like, I don't know, you're going to be flooded with swords in the economy and they're going to kind of lose their value. So we could talk about like some Sybil resistant ways that you can distribute items. One really easy way is to sell them, but as players, it's more fun to earn them. So we'll talk about that. So let's go ahead and just do this. It's going to go ahead and do that. Sweet. So I think we're going to run into an issue because the Open Zeppelin version, the latest one, doesn't really use counters, I don't think, but we'll see. All right, so let me pull this over. And I need to install Open Zeppelin contracts, which it's telling me to do, which is perfect. So let's go ahead and do that. And so you could see that I'm also using NPM to install Solidity contracts. That's also going to get installed into node modules. So if you go in here into Open Zeppelin, you're actually going to see these contracts that are Solidity contracts. Those are the builds, the artifacts from the contracts. But if you go in here, you could see actual Solidity contracts that we can import inside of our Hardhat environment. So just like you can do that with JavaScript, you can kind of import Solidity. It's been set up to use node modules just like we do with JavaScript libraries. Cool. So there is one issue here, which is I don't think so. Open Zeppelin contracts, I don't think that counters is the common way to do this anymore. So if you go in here to Open Zeppelin contracts utils, I don't really see a counter. So let's just ask maybe to update. Can you update this to Open Zeppelin? I believe, let's see what version we're using. Sometimes it gets the versions wrong. Open Zeppelin 5.1. So we're on 5.1, which looks like to 5.1, which looks like it doesn't have the counter util anymore. So maybe in this case, it would have been a little easier just going straight to the documentation, but cool. All right. Sweet. All right, that looks better. So now we're not getting that red squiggles for the counter library, and we have a sword, SWRD. There we are, right? So the sword contract is going to be a collection of NFTs. One of these tokens is going to be Tabo sword. One's going to be GGG sword. One's going to be Dan sword. One's going to be Nan sword. So cool. We'll go ahead and mint ourselves a sword and we'll test this. That's the first thing that we should really do, is just test that this is working okay. So I'm going to call this test over here sword test. And let's make this a little simpler. So I'm going to ask again for, and then we'll take a look at the code, what it does here. But can you change this? So you could see that the context it has is sword.ts inside of the test. We also want to add sword.sl, sword.sol. Can you change this sword.ts file to be a test of the sword NFT, where we can mint ourselves a sword and then be sure that we are the owners of that particular token ID. Okay, that's really what I want there. So yeah, it's going to go ahead and deploy all this. And then we can take a look at this and change around a little bit of this so we can get familiar with this. Cool. All right, let's close this out. So it did a few things, right? So first of all, in Hardhat now, in the latest versions, there's this concept of like a fixture. And with fixtures, what you can do is you can do some like setup code, and then you can return some values here. And then inside of your tests, you can say like load fixture. And the load fixture is just, it's a more performant way of doing setup code. We used to do it in like befores, but this actually makes use of like some blockchain timestamping stuff where you can like go back to a particular state of the blockchain. So it's just a lot more performant. So now you'll see fixtures being used in Hardhat tests. And this one's going to go ahead and load the fixture here for the sword fixture, which is going to run this, which what this is doing here is first it's getting 2 accounts from our default signers. And then it's going to go ahead and get the contract factory for the sword, which is everything it needs to go ahead and deploy the sword, which is the bytecode and the ABI. And then it's going to go ahead and deploy that. And then once it's deployed it, it's going to return that contract to us so we can make use of it, as well as these 2 other accounts, or these 2 accounts here. So we can make use of those in our tests. And then you'll see here in the first test that we are loading up the sword. It's minting a sword, and then the first token ID should indeed be 0. And what we should expect is that the owner of the token ID is equal to the person who called sword.mint. By default, this is a little weird for people coming in here for the first time, but by default, when you call contracts like this from a contract factory that's been deployed, the default context for the person calling this contract is the first account that comes out here, this owner right here. So that's why in this expect right here, it's saying expect that sword.owner is going to be equal, or sword owner of the token ID is going to be equal to the owner address, is because this right here by default is going to be set to that owner address. If we wanted to like use somebody else here, we could say connect, and then we could say like other account and pass in other account to mint it, and then it should be equal to the other account. We can test that out in a minute just to make sure that works, but let's take a look at the rest of the code here to see what else it's doing. So again, it loads that fixture. It's important to note that fixtures here are not going to, fixtures here are not going to, every time that you run a test, it's going to like reset from the beginning. So it's going to rerun or it's going to sort of reset to where that fixture starts. It's not going to pick up from this state, right? So it's going to reset from where the fixture ends before the state of the last test that you ran. So this mint right here will not affect this test, right? So now it's testing mint multiple swords. So it's minting sword 3 times, and then it's saying, let's make sure that the owner is the owner of all 3 of these tokens. And yeah, that's great. So the other thing we could also do is await sword balance of owner address to be equal to 3, right? And if what I said was true, that this sword mint up here doesn't affect these sword mints, this test down here, then it should only be 3, right? Because this owner should have 3 NFTs through this sword collection, 3 swords. So let's go ahead and run this. We're going to say npx hardhat test. And that's going to run all the tests in our unit test there. Looks like it's passing, right? So if we minted 4 swords, all 3 of these should test, but the 4th one should fail because the balance of the owner should be 4. So it's always good to like go and check yourself, make sure that you understand how your unit tests are working, play around with them, break them, do stuff like make sure that if we connect this to the other account, right, and we try calling this from the other account and we say .mint, and we got to pull this out from our fixture here, that the owner of the token should be the other account. It shouldn't be the owner. So right now I expect it to break. If we run this, the first test there, you can see that it's getting this error where one address is not equal to the other. That's because this is now like the other account is the one that minted it. So it should be equal to the other account. So now if I run it like this, we should actually see that it's working, right? Cool. Awesome. It's always useful, especially if you're going to have AI generate your code, to just like go around and play around with it, understand what it's doing, because then you could use it, to like make it faster. Like this definitely made it a lot faster for me. But then you want to make sure that you understand like what it's doing. You want to make sure that it's testing all of your assumptions, everything you would like it to, and then you could add more code as you need to test more things out. Okay, great. So that's pretty good. What we want to do next, let's move into our worlds, right? So let's create the world. So the world is going to be another contract. And, so again, the worlds, we're going to have like my world, GGG's world. Let's go ahead and just do this ourselves. That's interesting. No, I don't want it to be in ERC 721. It's not going to be in ERC 721. A world is going to be a place where we can drop the swords, right? And Dev Relevant had a great question, which is like, do we have to trust the worlds then with our swords? And the answer is no. It's really just there so that there's an incentive. There's like a monetization for that world, right? We're really just putting the incentive, the collaboration incentive on chain. That's really the purpose of the world here. So it becomes like a database that you could read from your server to say, that sword is in my world. They paid for that sword to be in the world. And so therefore I'll read it. So let's go ahead and do let's do a function here called import item. Let's tell AI what we're doing because it might help. So what I'm planning on doing is let's create a function called import world, which will import item, which will transfer from the sword to this contract. Cool. All right, that's pretty good. It doesn't have the IRC 721. We're going to have to import that. There it is. So that's going to come in from OpenZeppelin as well. If you're not familiar with smart contracts, definitely recommend going through the Solidity course on Alchemy University. We go over stuff like interfaces. I stands for interface here. So it's not the ERC 721 contract itself. It's more like an interface that just explains what a contract should look like. If you go through the course, you'll understand why we only need the interface. And you'll understand how message calls work. It just, creates the data that needs to be sent over the message call here. So we have the interface, and we're saying this sword right here, this address that we're taking in is an ERC 721. So we're going to transfer from the person who's calling this function to this address here, this token ID, right? Cool. So that should import the item. And then what we're going to do from there is let's go ahead and emit item imported. That's pretty good. And what was it suggesting? We need to create an event. I like that. Okay. So here's an event. So events are going to be a little important later on. We're not going to really go through them today, although we will see them in the logs, which is super important. But this will be a really important way for you to be able to read from your application when a sword is moved from world to world. So when you're running your game server, you're going to want to pay attention to these events. Either you'll index them through something like a subgraph, or you'll index them in your own database by listening to these events as they occur. And whenever they occur, you want to keep track of where that sword is so that you could like put it in your database and say like, oh, the sword is now in my world, so I'm going to render it for this user. And if the sword isn't in the world, then you want to like sort of yank it out of their inventory as soon as that event has occurred, right? This is sort of an interesting thing there that you got to like, that the on-chain stuff can like impact your world there. And you need to be thinking about that. It'd be kind of funny if like a game server, you were like in the middle of battling something and then like a trade went through, your sword sold, and then all of a sudden like your sword's gone. Maybe don't put it on the market when you're going to go battle something. Okay, so that should be the import item. The one thing that I do need to do here is keep track of, so this is to dev relevance question, which is we want to make sure that the only person who can then export the item, take it out of the world, is the person who owns it, the initial person who owns it. So let's keep track of the original owner of the sword. So the original owner here, and then we need to have like, okay, so there's a little bit of a tricky thing here, which is that we want, so that's going to be the address for the token ID. No, we want this to be, it should map the address. It should map the address of the owner to the NFT to the token ID. That's really what we want. We want all three, and I'll tell you why. Let's go ahead and do that. So let's call this like, token owners. All right. It's not really coming up with it for me. So what I'm going to do is, there we go. So sword, so this sword right here is the NFT collection, right? This is the actual ERC721 that we deployed. And then this is the token ID. And we're going to keep track of who that owner was. This way, in our export function, the only person who can export it is also that person. So let's go ahead and, we got to change this guy around now. So now this is a mapping from an address, which is the NFT collection, to a token ID, to the NFT. And that's really what we need to keep track of. And maybe we make this public. And that way, if you're reading this from your game server, you would know who the owner of the sword is. Sweet. So now we want to let's create an export item. Yeah, that's actually pretty good. All right, cool. So export item is not going to do this. We really want to, well, actually, I guess that works. So the export function here, the export item is going to transfer from our address to the original token owner, the token ID. I think we should only allow the person whose sword this belongs to call this function, even though in this case it is sending it back to them. We do want to just like require that only the owner of the sword, the original sword who put it in here, is the one who's allowed to actually call this function. So this is going to say like, okay, only the person, the message sender, the person calling into this function must be the person who initially put this in here. Otherwise, you're not allowed to call this function. So that way, like, I don't know, like I was talking about before, you have somebody who's battling a monster with a sword, and then all of a sudden somebody exports it out of the world, and you're like, oh, where's my sword? Right? So only you're allowed to call that function or set it up so that you can. And then we're going to delete the token owners. And then finally, let's emit an item exported, and we'll create another event. Where's this event? Let's create another event here. Event item exported, and our item exported is going to be a sword and a token ID, just like this one. And we'll emit that, and that way you can keep track of when that's happening. Great. I think this is everything for our world, as far as I can picture it. Now, this would be the simplest version of a world. I think you could do a lot more here with it if you needed to. But this would be everything that we need to do in order to create that collaboration incentive via Gasback. Because automatically, when you interact with this world and you generate gas against this world by running its code, you are going to be incentivizing that world owner to actually be rendering the sword, to be doing something with the sword here. There's maybe a good thing to be doing, which is like, Maybe making it so that you actually, as an owner of the world, you tell this contract contractually which items, which NFT collections you are going to render. And so anytime that you're going to like render a new collection, you add it to the world. And so that way people don't like import an item and pay you to like bring a item into your world and then you don't even render it on your game server. But you could imagine that UIs could do that, right? Like if you have a UI for your game and you want to allow somebody to import something into it and you know you don't render that item, you just say, oh, hey, that NFT address, that's not one of the items that I render, so I'm not going to allow you to import, right? So you can handle that at the UI level, or you can handle it at the smart contract level. That's kind of up to you. There's a lot of like additional things that you could potentially add in here, but I think this is pretty good for the basics. Cool. Question?
No, Dan, probably if you want me to spend 1 minute to do a quick recap of my own words and you let me know if I'm correct or not, just to use different wording
Yeah.
and put it on a real scenario. Okay, let's say that I'm a user. I acquire in some way an NFT from the Sword NFT contract. So I got the NFT 12, that is a particular sword. So I came to this world and I, and only me, call this function called import item and can delegate, donate, import, or export from my account to this contract account my NFT to this world. And then when I want to move on to another world, want just to give my NFT back on my address, my account, I call the export item that I will receive again, and only me can call that function, public function, and I will get back my NFT on my own account. This is the beauty of smart contracts, that you can define what is allowed, but also what is not allowed. In this case, on a sport item, if you never claim back your NFT, that NFT is stuck on that contract. No one can send you back from another account or contract account, and no one can burn it, and no one can transfer or sell it or whatever. It's your only account that can claim it back to the original account. So it is probably a good recap. Do you think?
Yeah, absolutely. I think that was super helpful to put it in your words, and yeah, and you explained it perfectly. So that's
Thank
really
you.
helpful. Yeah, and yeah, I think that's really important to note that like even though maybe GGG or maybe I will be deploying this world, like this might be Dan's world. Realistically, like the only thing that I get out of this is I get the money that comes through for gas back, right? I have an incentive as the world deployer to create a game that makes you want to bring your sword into my world because maybe I have some content that allows you to use that sword to like battle some monsters or something, right? So for Dan's world, it makes sense for me to like read from this database for my games. You could even imagine that if this world becomes big enough that I delegate my gas back to a DAO, right? To an organization, and that organization pays out artists, it pays out game developers, it pays out anybody contributing to the project. So that way, like, you know, we figure out the best way to basically fund everybody who's like affiliated with creating this particular game. Or you could keep it super lean where each world is like an independent developer, like one developer who's building their own version of the game. And I can imagine both sort of scenarios where you have, you know, maybe teams of like 5 to 10 building game, you know, servers, you know, or you maybe have one person who just wants to create the world themselves. It's super interesting.
Infinite possibilities. Yeah,
Yeah.
it's a good. This approach is a good approach for royalties, where you can get some part of the gas back to the NFT collections creator artist. And I think you can borrow your sword to anyone else. If you're not going to play, you can borrow that and get something back. A lot of possibilities there.
Yeah, it's really cool that like this unlocks that sort of idea of like I mean, because these NFTs themselves kind of live separately from the worlds as far as collections, you could imagine other contracts to do things like, yeah, rentals and things like that, right? They could have their own sort of life outside of these worlds that could then maybe the person who's imported this item is not even a person but a rental contract that allows that person to import the item, but if once the rental period is over, it exports the item out of the world and automatically sends it back to the initial user. Something like that you can imagine being pretty cool as well. So, yeah, that's a really good point. I think what's interesting here is like this is not that much code, right? And this is like a revenue sharing system, right? It's a neutral revenue sharing system, something akin to like maybe what YouTube does or like what Roblox does, but baked into the smart contracts, baked into the blockchain, right? So this is actually like a revenue sharing system that we could all transparently agree to and, you know, potentially change or as a community, like move towards a particular standard for what worlds should look like and how we want to do incentives. Like, is gas back the, you know, perfect incentive here where like this is exactly what we want to do? Do we need to like incentivize it a little bit more? So maybe there's a little bit more of a payment on import or a little bit more of a payment on export, right? You can kind of change it to tune it however you'd like. And then, you know, if users decide that it's too expensive to import or export to your world, they just won't do that, right? But yeah, that's the beauty of it. You can define for your world what you want it to be, and then other people can do the same for their worlds. And there's a good
That's
reason
the
for
beauty
that.
of smart contracts. We have a good question from Tebo. I don't know if you have enough time, but just I will drop it. Tebo is asking, does the gas bag go to the deployer address or the contract address?
Yeah, so
Or
there's
you can define it. I don't know.
yeah, you could define it. So this would actually be a good thing to pull up. So they actually have this on Shapecraft. So if you go out here to Shapecraft, there's like an article on Gasback, and it'll teach you how to do Gasback here. So this is where I would recommend checking it out. We're supposed to do a workshop on Gasback hopefully soon, so I'll be able to show you exactly like how that works. At the moment, I know I actually haven't dug into exactly what the ownership function is, but basically you just need to define like I think it's just defining like an owner or a function that can read who the owner is. So you can delegate who the owner is. It might be as simple of like having a function like owner of or something like that, and then just responding with who the owner of this world is, where the money should go to. Um, it's something simple like that, but I'm not actually sure off the top of my head what it is. But you will have to define that for the world. So I'll make sure to get that in there before the hackathon starts, so that you have that defined as well.
Awesome.
Cool, great question. Sweet. All right. So that is, yeah, that is everything really that we wanted to do. Like if we look back at the, sorry for the infinite window there. If we look back at our Excalidraw, this is really everything we want, right? So if I deploy a world and GGG deploys a world, Tabo's sword, which could be token ID 12, can move between our worlds. And Gasback is going to pay us according to all of this functions that are being called as we import and export these swords across these different worlds. So if these games down here are fun, which is the end goal, right? We want to make a player experience that is fun. You could imagine that GGG hosts a website somewhere with a fun game, and I host another website with a fun game, and you could just go in between them, taking your sword with you, taking your avatar with you, taking whatever you want. And if we can create that as a seamless player experience, you can imagine that working really, really well. I also think there's room in this model, and we'll talk about this next week, to do gas abstraction. You would definitely need somebody who is willing to pay that upfront cost as like a entity, as like a wallet or something like that, who may be willing to pay these gas costs here to transfer between the worlds, because they know that the user relationship is more important, right? Because maybe when you sell the sword, they take a cut of that, like how you see like fees in swapping markets like Uniswap. That may be more lucrative to them, where they wouldn't mind like allowing you to transfer between these different worlds maybe a certain number of times per day or something like that, so that this would be like really, really seamless for the user, where you could just go from one game to another without really having to think about this. So that's something I want to think about a little bit more next week, is what the player experience will be, because ideally you're just going from one website to another or one platform to another, and you are just jumping in and your sword's there because you said, yeah, I want to move it, right? The more seamless we can make that, the better it will be for the users at the end of the day. And if it could be as simple as just like, going to a portal and redirecting to another website and you're in a different experience, that would be ideal. Cool. Awesome. So let's go ahead and just finish this out, right? So what I want to do is I want to deploy sword and world to shape Sepolia. So what I'm going to do next is I'm just going to write one more test. That's going to be the world test. And the world test, what it should do is it should just make sure that we can import an item and export an item. And the only person who's allowed to export the item is the person who, owned the item to begin with. So let's go ahead and just ask AI to sort of do this for us as well. Just to make sure it's working properly, right? So we'll give it the context of sword.ts, also sword.sol, and also world.sol, right? So it knows all these things. And we'll say, hey, could you make a test for world.ts that will test that we can import an item into the world, then make sure that we no longer own that item at that time. Next, a test that somebody else cannot export the item, right? That was dev relevance question, right? And we have that require built in there. So somebody else cannot export the item out of there. So we're going to have a test and say, hey, make sure that nobody else can export this item out. But then let us export it and make sure that we have ownership of the item once more, right? This is kind of what we're looking for as a test, and hopefully it'll get that mostly correct, and we can fix whatever's issue. So it's deploying the sword contract, it's deploying the world contract, it's minting a sword for testing, all inside of the fixture. And then it's saying, okay, when we import the item, it's going to go ahead and approve. This is the approved transfer from flow. So the first thing that you need to do is you need to go to the sword NFT collection itself and say, I approve the world to go ahead and import this sword. So the next thing you could say is go ahead and import the item, and then the world pulls that sword over. That's the approved transfer from flow. It's a little hokey. You could also do this. There's another way that you could do it where you just say that you want to transfer the sword over to the world, and then the world can kind of react to that code. That's another thing you could look into. But and then this is the should prevent unauthorized export. So if you approve the item and then you import it into the world, then you expect that if another account tries to import or export it, it's going to say, hey, you're not the owner. And that's the message that we programmed on the contract. And then it's going to allow us to export as the original owner and then test that that's working. So that looks like everything I asked for. We'll see if it's actually working. Right now I'm getting red squiggles because I got to go recompile everything. So if I do npx hardhat compile, I expect these to go away because the typings are going to be generated. And now you can see that it actually recognizes that world item. And then, yeah, it looks like it's pretty happy. Claude generates really good code. This sort of stuff is like perfect for AI, right? Because it's like you're just trying to do like databasey stuff, and it really gets that kind of stuff really well. So like tends to be pretty close to what you want. So whoops, okay, here we go. npx hardhat compile, and again we'll try to break it if it works. Oops, test. All right, so it's working. So that should spook you a little bit, right? Like, why is it working? And you want to test at this point, like, is everything actually working the way you expect? All right, so let's say let's do a couple things to make sure that this is working properly. So first of all, let's just make sure that you have to approve the sword before it can be imported. That would be bad if like anybody could just import your sword into the world. We have to like approve it first to the sword contract. So you can see that if I take out the approve, it's actually giving an ERC 721 is insufficient approval message, which is a pretty good error. So we have to approve it. That's good. If we try to import it, let's try to import it with the other account. So, oh, actually, this is interesting. I think you would actually be allowed to do that based on the way that See, this is a good test right here. I think we might actually be able to, but by the way that I set this up is once you've approved it on the NFT, you might actually be able to, from another account, import the item. And maybe we want to allow that. That's kind of weird. Probably want to disallow that, but I actually think this will work. And then we could like make it so that that won't work. Oh no, it won't work. Okay. So it's saying ERC 721 incorrect owner. Okay, so the ERC 721 contract itself. So this error must be happening inside of Open Zeppelin because that looks like a very specific error that they've encoded into the ERC 721. So I'm sure we could find that if we like looked inside the Open Zeppelin ERC 721. So if you go to token ERC 721 and you go into the actual contract, we could probably find it. There it is, right? So even on transfer from, if you're not the person that's calling this is going to say incorrect owner. I'm kind of surprised by that because I thought once we called import item inside of, sorry, there's too much on a small screen here. Let me get rid of this. Once we call import item over here, it's going to do a transfer from the but it's doing it from the message sender to this address, right? And the message sender in that case would be the other account. So yeah, that wouldn't work. It was already baked into our model. Yeah, so it's good to test, right? So that actually is okay. That's fine. So we broke our test cases a couple times, and we're making sure that these are actually working properly. And then prevent unauthorized export. That seems to be working pretty well, right? If you connect the other account, it doesn't allow you to export. But then once you export with the original owner, it allows you to get your token back. So then you become the owner again. And this is like dev relevance question. Only you can withdraw the sword. It's only there to create that like collaboration incentive where you earn gas back for being a deployer of the world. Sweet. So I feel pretty good about the test there. Let's go ahead and deploy it, right? So let's deploy this. We're going to deploy both the sword and the world, and then we're going to interact with them a little bit. So let's start a new chat here. Can you change lock.ts to deploy the sword and mint 3 of them to the account calling this to the first account in our configuration. Okay, cool. So the one thing here I forgot to do was give it context of the sword. So I'm actually going to fix that so that it knows what I'm talking about when I say the sword here. So let's do that. And then I think it's going to generate slightly different code there. Cool. So now it's calling mint on the sword. And then we only really want to return the sword here. That's just the way the ignition modules work. But we'll do this. And then we'll return the sword. The ignition modules are set up in a way where you can actually depend upon one thing to be deployed before the other one. There's sort of like a really important thing here for smart contract development where like when you're deploying stuff, you expect the contracts to all go out in a very specific sequence with state that's like easily able to be replicated, and ignition modules allow you to do that really well. So this sword needs to be returned. So if you have another module that's depending upon this module, it can like pull that in and everything could be executed according to plan. So the ignition modules are really great for that sort of thing. Here it doesn't want async, and I don't think we're using await, so we're fine there. And you can see even these calls here, it has it like depending on the previous call here. And I think we're also supposed to put in IDs. So you're supposed to say like each one has like a specific ID for each one of these calls in ignition. So I believe that's necessary there. So each one of this mint 2 is going to depend on mint 1, and then mint 3 is going to depend on mint 2. That way, like it can make sure that all these things happen the way you expect them to happen. Because you can imagine that when you're doing a mainnet deployment, especially when you're using real money, right, on a real network, you want to make sure that everything goes exactly according to plan. So you want to like declare exactly like what you're trying to do. And this is what these ignition modules really help you do. So what we're going to do is we're going to deploy that contract, and then we're going to mint it 3 times to the person who is the initial owner of the sword contract that initial address. And I'm going to set up another address that we're going to have some shape Sepolia test on in a second. So let's call this the sword module.ts. And let's also create a world module while we're at it. And then we'll test these things, and then we'll go ahead and deploy this on Shape as well. So let's also create a world module. Okay. Now, can you create a world module that tests or that deploys the world? I think that's actually pretty straightforward because we don't want to mint anything. We don't want to do anything else. Contract. Yeah, that's pretty straightforward. Okay, sweet. Again, it's trying to do async, but it doesn't want that for that. Cool. All right. So deploy the world contract. It takes no parameters, right? Maybe a more complicated world would. You might want to take some parameters, but if, here we're not going to, and it's just going to return the world. That's super, super simple. Okay. And then, yeah, let's go ahead and do this, and then we'll see where we're at. So in order to deploy this, we could deploy it straight to Shape Sepolia, which is the testnet for Shape, or we could deploy this to like a local node. And for a local node, what we could do is, let me like clear this out and create like a new terminal here. For a local node, what we'll do is we'll run npx hardhat node. That's going to run like a local node. It's going to give me a bunch of accounts here. And then from my other terminal, I can go ahead and deploy these two modules. So I'm going to do npx hardhat ignition. And let's do deploy modules. Let's deploy the sword module first, and then we'll make sure that that's working. So I'm going to do network is localhost. And okay, that went through really fast. And if it's working properly, it should have deployed it over here. And you could see there's our mints. And yeah, so I'm pretty confident that this worked. There's a contract deployment and then a bunch of mints. So yeah, that worked pretty good. So there's our sword address right here. Cool thing about ignition is it keeps track of all the things that you've deployed. So every time you run ignition, it'll tell you what the addresses you deployed, and it keeps it specific to the chain. So 3113 or 31337 is the ID code for your localhost elite, I suppose. So that's going to be like our local chain where we're deploying all that stuff. So it keeps track of that as we go along. So if we want to deploy a world as well, we can do that by just doing world module.ts, and that's going to run it there. So now we deployed a sword and a world. It is telling us that maybe we should have like included these in this module. Again, I'm not, the best. Maybe there's like a dependency or something that we could put in here, but that's all right. We've deployed these, so I'm just going to leave that and let the warning be. And what I want to do now is just test that that's working. So this local node right here is a node that I can talk to see if the state is working properly, that we've deployed both the world and the sword. So let's just see if I am the owner of 3 swords, right? We've minted 3 swords. That's the only thing I want to really test right now is like, and then maybe we could like import and export the item, right? And then we'll do that on chain as well. So I'm going to write these in like a scripts folder. I'm going to create a script, and I'm going to say, let's do check swords.ts, and there's my sword address. Let's tell the AI to go ahead and create a. Can you create a Hardhat script that checks to see the balance for the first account in my config, and make we'll just log it out, checks the balance of swords NFT for the first account in my config and logs it out. And the sword NFT address is this. So maybe it'll be able to put all that in. Sweet. So put in the address and everything. Cool. All right. That's a Hardhat script right there. So what's it doing? It's grabbing the first account out of Ether's get signers. This we can configure. This we can configure via Hardhat config, and we will in a moment when we need to like go and create a private key that we have some testnet Ether on. But for now, this is just going to grab the first signer. That's just going to be one of those accounts that was generated like when we first created this blockchain, it's going to grab this account right here with this private key. Never use this private key. Many people have, and they've lost their money. That's not a private key that you should use. It's generated every single time. So keep that in mind. All right, cool. So that is the account. And then this is the sword address right here that we already deployed on that local network so we can interact with it. And what we're going to do is we're going to call on that contract at that sword address. We're going to call the balance of that first account, and it should be 3, right? Because we minted 3 swords, and the owner should be the owner of token ID 0, token ID 1, token ID 2, because it's going to count each time. So if we were to run npx hardhat run scripts /checkswords.ts on my local host network, it should return 3. There it is, 3, right? So I've minted 3 swords. There's my balance. It's 3 swords. If we want to import and export these swords, we can check the balance now because we have that script. So when we go to import a sword into a world, let's go ahead and also ask AI to do this one. And then the export should be easy from there. Can you create a Hardhat script? Let's give it sword.soul, and let's give it also world.soul. That will take a particular token ID. Let's use 0 for now, and call the sword NFT contract at, let's get our address here. The sword, oh my goodness, I don't have much room on the screen. I'm so zoomed in for you guys. Okay, and call the sword NFT contract at this address to approve transfer to import the item into the world at this address. And then yeah, that should, and then that it should understand what I mean by that, I think. All right, cool. So it's got the sword address in there. It's got the world address in there. It's getting the first signer. It's getting the contract instances. And then it's first approving the world to go ahead and spend my token ID. And then we're waiting for that transaction to go through. And then we're importing the item next into the world. And then once it's imported, it's there. So let's go ahead and see if that works properly. If it works properly, then our balance should go down by 1 to 2, right? So let's go ahead and just check that out. So I'm going to go ahead and say npx hardhat run, not check swords, but import sword. Oh my goodness, I misspelled sword. There was a Q in there. Import sword. All right, so if it imported properly into the world is now the owner of the NFT, but keep in mind, it can't do anything with it. I'm the only one who's allowed to export out of it. So we'll just go check our swords to see that I only have 2 now. There it is. We have 2, but we can export it, right? If we create a script to export it. The other thing we might want to check now, it's interesting. The world is the owner of the sword at this point, right? So if we go in here to check swords and we change the address that we're looking up, let's create the address is going to be, instead of my account address, let's plug in the world address. The world address should now have a balance of 1. Right? Because the world is the owner of the NFT at this point. It like holds on to it. So let's go ahead and run check swords for the world, and we'll see that the world owns 1 NFT, right? There it is. Cool. So we'll go back to the account address. That way we can, well, let's export the sword, and then we'll see that the world no longer has ownership of it. It'll be nicer to see this on a block explorer in a moment when we put this on Shapecraft. So let's go ahead and export the sword. This is going to be so similar to import sword that I'm not really going to ask AI to do anything here, right? We're going to have that signer, and then we're basically going to, well, we don't even need to approve, right? So that's gone. We just need to export item from the world, and we'll say exporting sword from world, and we'll say successfully exported from world. Cool. And you could imagine that maybe there's also a better way to set up the worlds where we could, instead of exporting to our address, we could designate where we want to export them to if we wanted to export them to another world. But in that case, then that's interesting, right? It may be better not to do the approved transfer from flow, because then the contract's going to need to respond to that transfer. So maybe the approved transfer from flow is not the right way to do it. Yeah. I'll create a new version of this that also has the gasback owner in it, something that will be a little bit easier to use. But now that I'm thinking about it, if you wanted to export an item into another world directly, that world needs to have the ability to be able to respond to that. So it'd actually be better to be a NFT receiver, is what it's called, an ERC 721 receiver, in which case you implement this function on ERC 721 received, and then you respond to that and like update the mapping from there. I think that's probably a better model for this instead of the approved transfer from. But sort of thinking out loud here, this is up to everyone really in the hackathon to think about like the best model here. I'm not claiming to have like this all thought out all the way through. Just really the collaboration incentive, I think, is the key. Cool. All right. So now we're going to go ahead and export the sword. Let's go ahead and do that. So we're going to say export sword.ts. So if it's been exported, then if we go to check the swords, there should be 0 in my world now. Right. And if we go back in here and we plug in the owner address instead of the world address, we should have, it should be the account address. We should have 3 swords again because we've exported it back into our account. So now we are the owner of the account again. Okay, that's perfect. So last thing we really need to do here is put the swords and the worlds out on Shape Sepolia. And that should be pretty simple because we've already set everything up the way we need to. So the only thing we need to do here is let's create a add Shape Sepolia to the network config. And so perfect. Cool. So this is how you do that in Hardhat is you add networks and then you name it. So you can name it Sepolia or you can name it Shape Sepolia. And then you can pass in the URL. And then we're also going to have a private key. Again, please don't steal my private key while this is live. You can take it after, but I'm just using it for the testnet stuff here while we're doing this example. And what I'm also going to do here, because you see here, I'm like passing in the network flag. In order to make it so we don't have to pass in the network flag, I'm just going to make the default network here Sepolia, so that whenever we run these scripts, it's automatically just going to run on Sepolia here. The Sepolia URL, we go grab this from Alchemy, so that way we can hit it directly. Let's go out to my Alchemy account. We'll get a Shape Sepolia URL. So Dan's first app, sure. And we'll go to networks, Shape Sepolia. We're going to go to Sepolia here. Here's my API key with my URL baked in there. You probably want to put these in environment variables just in case you forget and then you pass them up. Even though this is testnet ether and this is my API key, maybe you put this live one day. I'm going to recycle these particularly, so I don't really care for now. But this private key, what we're going to do for this private key is like I did last time, I'm just going to generate the private key. So let's go ahead and do that. I'm going to do node require crypto, and we just need 32 random bytes, right? So random bytes, 32, toString, use whatever entropy I have on my system and turn it into hex. And there's my private key. So we're going to put that into an account. One thing I do need to know is what is the address associated to this so we can mint the sword to that address. I think we'll probably need that. Yeah, because when we go to check source, no, maybe not, because we'll get it right here. Okay. Yeah. So let's go ahead and so we should be able to, yeah, I think this will work out okay. This first account right here now is going to be that account that I just added in for Shape Sepolia. So when it does this ethers get signer, this ethers is actually, it's a version of the ethers library that's like hooked into Hardhat. So it actually already has loaded up the Hardhat config. So this account actually comes out of that network configuration when I'm running this on Shape Sepolia. So it's going to be that account now. So the same script doesn't need to be changed when I switch to networks. I just need to switch the network configuration, right? That's super handy. So you could deploy to many networks and you could test it all out on your local network and then go ahead and run it somewhere else. So this should work pretty well, where we should be able to check. I should be able to deploy the modules, and then I should be able to check that I have 3 swords in my account and then do the whole thing all on Shape Sepolia, and we'll be able to see it on a block explorer. So let's go ahead and do that. I'm going to close out of this other terminal that was running my local host because I don't need it anymore. So there goes the blockchain. Boom, gone. let's go ahead and do this stuff. So let's do ignition, npx hardhat ignition, and we're going to deploy, let's do the sword module first, and it's going to mint 3 swords to me. So let's go ahead. Oh, you know what I do need to do? I don't have any testnet ether inside of that account. So I do need that address. So that way I can, let's just log out this address right now. So that way I can know where to pass that off to. Oh, it's going to log it out and then tell me the balance. So let's, yeah, whatever. Let's call an npx hardhat run script / check swords .ts on shapes of Polya, and it's getting mad. Okay, because this didn't do anything, because that sword doesn't exist on shapes of Polya, but I just want to log out the address for now. So let's just log out the address. I just want to be able to send some gas money over, because this is going to be the account that I'm going to be doing all the deployments with. So if it doesn't have any money inside of it, it doesn't have any ether, then we can't deploy all of our scripts. So I just really wanted to get the address right there, and then I'll put this back to where it was. So now what I can do is I can come over here, and I have inside of my account 0.08 ether on shapes of Polya, right? There's shapes of Polya testnet. So what I'm going to do is I'm just going to send over some to this account, and this new MetaMask UI is really throwing me off, man. 0.005. We'll send that over. That should be plenty to our account, and then we'll be able to deploy once that comes in there. So now let's go ahead and deploy our sword module. That's what I really wanted to do. So npx hardhat ignition, and we'll do sword module on shapes of Polya. And if that works, yep, that's the one I want to do. It's going to send out the sword, and it's going to send out all the mints. That's pretty cool. With ignition, it's going to like batch them up too. So if you do this in a smart way, it's like, I probably could have let all 3 mints be a batch. They don't really have to be dependent upon each other, right? There's nothing in here that makes them dependent upon each other. It's just the way that it was like set up. So maybe that would have been the smarter move here, but that's okay. We'll wait for all these to go through. If we go and get my account over here and we go take a look at it on the block explorer, we should see that, for one thing, it got the ether that I sent over to it, and it's already using some of it. So now it's not at 0.005 anymore. It's already used some gas to mince itself 1 sword. And hopefully soon that'll be like more like 2 or 3 swords. There's 2 swords. And maybe if we refresh one more time, we'll see 3 swords. Yeah, look at that. All right, we're at 3 swords. So we got ourselves to 3 swords inside of the account. Now what we want to do is we want to import it into a world. So let's go ahead and do that. So the next thing we want to do is deploy the world module. So I'm going to be the owner of the world in this case. And that is going to go through. Bum, 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 bum. And then once we do that, we're going to go ahead and import and export the sword, and we'll see it actually move into the contract on Shapes of Polya. So here's our world over here. It should be a new contract out over here on the block explorer. So we see that there's no balance, there's no transactions, there's no gas used. As a world owner, this is the number that I really want to keep moving up, right? Because more gas used on my contract, the more gas back I'm going to get, right? So I can earn by having people just interact with my program, which is pretty cool. So let's go ahead and we're going to go ahead and import the sword into the world. So I'm going to call npx. So one thing with the import sword, maybe these would have been better off as like ignition modules, or like tying into the ignition modules. So that way, like I don't have to copy and paste the world address in here. But since we have this as this, we're going to have to paste in the sword address and the world address, and then we'll mess with token ID 0. But you could use 1 or 2 because we also have those in there, and we'll keep everything else the same. And then for export world, before I forget, I'm also going to update these to the values on Shapes of Polya. Cool. So let's go ahead and import sword. npx hardhat run script / import sword ts. And that should move the item from my account right over here, right, where I had 3 swords. Now if I refresh, I should only have 2 swords. Nope. One more time. 2 swords. Yeah, there we go. 2 swords. And then if I come over here, world should have 1 sword. Let's refresh. One sword. Sweet. So the world is the owner of the sword at this point, and this gas use ticker should move up as that transaction goes through and gets indexed on the block explorer here. Hasn't quite pushed it up just yet, but soon that will actually move up to keep track of the gas that was actually used against this contract. And we have one sword on the world. If we want to export this, now we can like see this go the other way, right? So we should be the only ones who should be able to export the sword. Now we can move this out of the world back into our account. And by doing that, when it was in the world, you could imagine this being rendered into our game that we're developing on Thursdays. And then when you move it out of the world, you can imagine that sword just being poof, gone, right? It's no longer in the world. So just like that, when we come over here to the block explorer, the sword is gone. But if we go over to our account over here, you'll see that the sword is back. There we go. Sweet. So we imported and exported the sword out of the world. We did everything here on Shape Sepolia that we said we were going to do. And yeah, there's a collaboration incentive, right? There's a reason why I would want GDG to go and create a world that's going to have users importing and exporting these swords because I'll just keep earning gas back for all of that.
Awesome. Amazing session today, Dan. Probably, I think it's a good idea for homework for the attendants to propose in the Alchemy University Discord, in the channel where we are sharing ideas, improving the project, the weekly projects. What cool ideas do you have for sharing that objects between worlds? The obvious one is to get the object back, the owner, the original owner, and transfer by itself to the new one. The other is, as you said before, get the possibility on each contract, but this should be on each contract, to receive an object and transfers on behalf the original owner that object without the need of the original owner to call the transaction, call the function. So I think there could be more than 10 possibilities how the object could transfer between worlds with or without the original owner participation, and on all the cases without losing the possibility of ownership and recovering the object by the original owner. But I'm super, super happy to hear more creative ideas from the audience, from the students and developers.
Yeah, the best standards always go through like a long period of, I hopefully these worlds are exciting enough and this idea is exciting enough that we propose like an EIP out of this, right? That would be super cool if we came up with a world standard that is like what you would expect the world to be like for these on-chain, off-chain worlds. And then we could agree upon a standard for what a world should look like. So what GGG was talking about, think about different ways that we could like handle ownership transfers that like accounts for every which way that somebody would want to use this world. Also, I mentioned this idea that you should implement like IRC 721 receiver. I believe this is the standard for it. It's on it's on ERC 721 for Open Zeppelin, where basically you are an IRC 721 receiver and you have this function. It's like on ERC 721 received, and instead of having it the way that I did it, which I think was the naive bad way of doing it, which was the transfer from flow. Instead of doing the transfer from flow here, you would actually just have an on ERC 721 received and you would respond to it. And so that way we don't have to do an approved transfer from as two separate calls. We could just do a call into the NFT contract and then transfer it over to the contract. And then the contract learns that happens because the sword contract would call this contract. So the standard for that is something like IRC 721 receiver. You could find that in Open Zeppelin contracts token. ERC 721. So it's probably in like, let's see. Oh, is it called holder now? Maybe it's called holder. Yeah. Okay. There it is. So it's ERC 721 holder, and it's on ERC 721 received. And you can implement this function. This should be virtual. So you should be able to implement this function here so that you can then add some functionality. So instead of doing it the way that I did with the world, where you would do this import item, you would do on ERC 721 received, and then you would return that selector like it did there, and you would implement that function so that this world would become an IERC 721 holder, right? That would probably be the better way to do it. So that way we could import items directly into another world. You could import and you could export, from one world directly into another world, and make sure that like the security model is set up properly there.
Sweet.
Cool.
So we see you again next week, same time, but also tomorrow for another session, right, Dan?
Yeah, tomorrow for another session. We're going to be doing game development. Tomorrow we're going to be talking about collisions on the server side and the client side, and doing tile sets. So I know somebody did a little bit of that. We're going to be doing a lot more. Yeah.
Are we going to use some cool sprites from the users?
Sprites
the students?
From the users. Oh, yeah. You know what? So, yeah, that's a good teaser. So there was somebody on Twitter, Danny something, his full Twitter account is escaping me, but he created a project. He forked the project and created a character select screen from Tabo's sprite. And so I think we should just start there, where we have a character select, and then Tabo has like NFTs that you can like distribute on Shapecraft. So we could use that as like, you have a limited unlockable character, which is already really cool inside of a game. So
super cool. See you then.
Yeah. Thanks everybody. Take care.
Don't miss it. Bye-bye. Thank you.